So in the identity section, we emphasize a lot on using Pythagorean identity. And Pythagorean identity allows you to change, sine x, convert that into cosine of x. The only thing is you needed a square, right? So we could square both sides and do that. The only thing is, when you square both sides of an equation, let's say I have x is equal to 1. Let me square both sides. I get this. Are these two exactly the same statement?
No.
The x is equal to what here? Obviously,
1.
1. What is x equal to here?
1.
Plus or minus 1?
Plus or minus 1. Do you see how I created an extra value for x here? So when you're solving equations, you actually do not want to square both sides unless you have to. Now if you have to, you do it, and then you have to check all of your answers because half of them might be fake. So here, you would have to say, well, if I solve that, I get this, but I have to reject -1 because that's the only one that's equal to. This is very obvious and straightforward example, right? So the better thing to do is this.
Turn it into tangent.
Yes, you divide both sides.
Like
Cosine
cosine 2x.
of 2x.
Plus 1.
Then you get √3.
Tangent.
Tangent of 2x is equal to 1. And tangent of 2x is equal to 1 over √3. Now we're back to our normal strategy, right? You let 2x equal to a. That'll make a in between minus 2 pi and 2 pi. Okay, so there you go. Okay, so quickly let me just sketch it. So that's 2 pi. Minus pi minus 2 pi. Just alright, how many answers?
4.
1, 2, 3, 4. You can also think of this as the circle rotation. Some people like to actually, I think about a. So let's say I have.
Go down.
Yeah. In the circle, right? How many different angles will give you the value of 1 over √3?
Tangent 30.
Here, right? And also here. 2 locations, right? So if you circle around twice, right? This is a rotation of 0 to 2 pi. This one circle. So if you rotate once. But if you rotate one more time backwards, how many different values of angles of x will I get? That gives you a ratio of 1 over √3. 2 more, right? That's 4. Does that make sense? I like the picture more because it's like I can see it all in one picture. This one you have to sort of think, oh, there's 2 in rotations, there's 2 rotations, there's 4. It's up to you. Some students like one more than the others. And let's stick with this because I've been talking about this way more than this one. Okay. So what is a special angle which will give you 1 over √3 again? Pi over 6. So it's going to be 7 pi over 6. Right. It's going to be minus 5 pi over 6 and minus 11 pi over 6. That's what a is equal to, right? Okay, and a was equal to 2x, so x is equal to everything divided by 2. Okay, that's the angles that we're looking for.